As we move through each topic, decide whether that topic is something you can identify as a strength, meaning, okay, if my GED really did take place today, I could get 100% of the questions in this category right now, or an opportunity, which is everything else. If you emerge from class with a list of opportunities, you're gold. Then that'll tell you exactly where to spend extra time after class practicing. Good. All right, so nice. Some of us are meeting me for the first time. I have some pictures to show you and also some math to impart. And I do certainly welcome participation. So this is your time that we're putting towards your goals. I'm sure you're a busy adult. I'm sure you had a lot going on today, but now's a good time to zero in on you. So lock in. If you would, please remove from your workstation any and all distractions. You know the ones. And plan to chat with us and vote in the polls. All right, so let's roll. We're going to first look at the number line. Please give me in the chat the two letters NL for number line. If you can be like, I've seen a number line before. Have you seen it? And if not, you can put no, which is totally fine also. Okay, a number line. So here's an example of a number line. You can see it has whole numbers on it. By whole numbers, I mean non-fractions. Oh, good, D. Awesome. And notice that as the numbers move to the right, the numbers get bigger and bigger and bigger. So, I mean, we have 1 here, and then 4, and then 10 would be somewhere up here, and then 30, you know? So moving to the right on the number line, the numbers get bigger. So notice what happens when we move to the left on the number line. The values get smaller and smaller and smaller. 2, 1, 0. Now we're in the negatives. So every number line works like this. Moving to the right, the numbers get bigger. Moving to the left, the numbers get smaller. Now, sometimes on the number line, you can have fractions. In fact, we're going to see that on a question coming up shortly. The same rules apply. As we travel to the right, the numbers get bigger. And you can see they do because on the left here we have 0. And then we have 1 on the right. So as we move to the right, the numbers get bigger and bigger. So let's talk about situations in real life where you might have had experience with fractions. It's possible if you do a lot of baking. You're measuring out a 1/4 cup of this, 3/4 of a cup of that. If you do mason work, or if you do woodworking and you have to measure and like cut at a certain at a certain spot. Also, if you shop for diamonds, 1 1/4 carat diamond is bigger than a 1/4 carat diamond, right? So there's so many real life scenarios where you use fractions and we might not even realize it. But just like the number line at the top, as these fractions move to the right, notice that they get bigger and bigger and bigger. Aha! Filling up oil in the car. Very good point there, right? And, even filling up the tank, right? A gas tank, 1/4 of a tank, 1/2 a tank, 3/4 of a tank. So, yes. Oh, Melissa Quilts uses fractions. I use them all the time. Lots of different things going on. A ruler would also have these measurements on it. So if you think about a ruler serves as a number line, really. Starts with 0 on the left and goes all the way up to 12 inches for a full-length ruler. So the number line going to the right, the numbers are always increasing. Now we're going to add on a little bit to this thinking and talk about absolute value. Debbie, good point there. Yeah, tool bits. Oh yeah, tool bits, totally, like 5/16 and yeah, totally. So let's talk a little bit about absolute value. Next, continuing with our discussion of number line. So the absolute value of a number is its distance from 0 on the number line, meaning how many steps is this number from 0. So for example, if you wanted to know the absolute value of 2, notice what is highlighted on the number line here, and you counted the number of steps from 2 over to 0. 1, 2, we'd say the absolute value of 2 is 2. It's 2 steps away. The absolute value of 3 would be 3. It's 3 steps away on the number line. Now, if you've learned about absolute value before, you might remember absolute value is often written with vertical bars around the number. So let me show you this example at the bottom. -2. So let's say we wanted to find the absolute value of -2. Your turn. How many steps over to 0 is it from -2? Yes, exactly. It's going to be 2. So notice that after the equal sign, we always have a positive number because we're counting steps. Steps are countable. So it's positive. The number of steps from 2 over to 0 is 2. The number of steps from -2 over to 0 is also 2. Good. So let's step it up a little bit with the absolute value. Remember, absolute value is designated by the vertical bars. I'm drawing them up on screen at the top. So those vertical bars really mean how far is the number inside these bars from 0. All right, so look at this little example coming up. In just a moment, we're going to be solving the absolute value of 2d plus 6. But we can't solve it right now because we don't have a value of d. But let's say that we were told the value of d is -1. Oh, 1. Let's make it easier with 1. Let's say d is 1. What we can do is then plug it in. Follow me here at the top. I'm going to put 2 times 1 plus 6. So we're looking at the absolute value of 2 times 1 plus 6. So if you were to simplify that out inside the absolute value bars, we're looking at the absolute value of what number? Aha, yes. So this would be the absolute value of 8. Aha, and what is the absolute value of 8? Like how many steps from 0 is the number 8? Aha, yes, 8. So I'm doing this up on top for you because you'll see at the bottom I'm going to bring up some of the notes, but the equal signs aren't lining up as nicely as they really could be. Check out the equal sign below that 2 times 1 plus 6, sorry, that is down at the bottom. But you can see a clear example up top there. So the absolute value of 8 is 8. Let's try another number in for D. Okay, let's put in -4 for D this time. So I'm going to head back up to the top. Oh, Jen. I want to make sure that the notes are clear so you can see what I'm doing. If D is -4, I'm going to write it as the absolute value of 2 times -4 plus 6. And of course, on test, I write this out, you know? All right, first, let's do the absolute value of 2 times -4, which is -8, plus 6. Nice. And when you simplify that inside the absolute value bars, what number will we find inside the absolute value bars when we do -8 plus 6? Aha, -2. Exactly. All right, and one more step. What is the absolute value of -2? You've got it. It's 2. So -2 is 2 steps away from 0 on the number line. Good. So notice that if we put in a new value for D like we did, and I've got it up at the top kind of neatly for you because the example I'm showing you at the bottom's got the equal signs in all the wrong places. Sorry about that. But ultimately, we're looking at the absolute value of -2, which is 2. Good. All right, so one more thing on absolute value before we go try a question together. Another way to talk about the distance from some number to another number is to talk about the positive difference. That's what's coming up next. So to find the distance between 2 points on a number line, you can find the positive difference between their values. I mean, you could count steps on the number line. That's one way. But look what you could do like arithmetically. So the absolute value of the difference. So let's say you wanted to know the distance from 3 to -2 on the number line. Well, if you just add 3 and -2 together, you get 1. But that's not right, because 3 is more than one step away from -2. 5 is right. So let's see the math that would get us to 5. We would have to do the absolute value of 3 minus a -2, which is the absolute value of 5. Now here, that seems like kind of silly because you could just count steps. But if they wanted the positive difference between like 47 and -19, then it will be really handy to have a way to solve that. So I'm going to work that example over here on the right. Let's say we wanted this, okay, this example. What is the positive difference between 47 and -19, otherwise known as how many steps? So to do that, we would do, let's see, the absolute value bars, and then 47 minus a -19. So let's remember that that would be 47 plus 19 inside the absolute value bars. Okay, so if we add those up, yeah, it looks like 66. So we're looking at the absolute value of 66. And what is the absolute value of 66? Right. Perfect. So taking the positive difference inside the absolute value bars will give us the number of steps. You can see that counting from 47 down to -19 isn't as easy as counting from like 3 down to -2, sure. So here's the way to find the difference between two numbers on the number line, taking the absolute value of the positive difference. Good. That's a great question, Connor. Come down and chat with Melissa about that. Positive difference. All right, good. So time for us to go check out a question together. And I ask you, if you would, to just take your time and read question number 1. So we're looking for the distance between A, which is this one, and B. So remember, to find the distance, we can take the absolute value of the positive difference. So that would be the absolute value of 7/8 minus 1/4. So before we get into the second example, what I've got for you on screen here in absolute value bars at the bottom, that would give us the distance from 7/8 to 1/4. True or false? The absolute value of 7/8 minus 1/4 is among the answer choice options as it's written right here. Is that there? Do we see that among the answer choice options, this one? Correct. We don't see that. First of all, answer choice options A and B have no absolute value bar, so that is just not right. But C and D are different. So to solve this, we took the positive difference from 7/8 to 1/4. However, you can also solve the difference in reverse. And by reverse, I mean put the 1/4 first. And then take the positive difference between 1/4 and 7/8. So let me show you what that would look like if we did it in reverse. Now, if you were to simplify 7/8 minus 1/4, and you were to simplify 1/4 minus 7/8, you might say, well, those are different numbers. One's going to be positive, one's negative. But they're inside the absolute value bars, which means the result will always be positive. So these two examples at the bottom are exactly the same in terms of their value. It's just that in the first example, it's A minus B inside the absolute value bars. Let me put that there for you. And in the second example, it's B minus A. inside the absolute value bars. Each of those would give you the right answer. So as we're looking at C and D, one of these remaining options is a match. Please share with us here in the chat. You can just shout it out. That's fine. The correct answer for question number 1. Good. C is correct. Yep. So it might have initially been a little bit worrisome that when we took the positive difference, 7 over 8 minus 1 over 4, that wasn't there in the answer choice options. But we can remember the absolute value of A minus B is the same as the absolute value of B minus A. So let's say you have questions on that. Let's say that you're not totally clear on what happened. Please come on down to the Q&A at the bottom and let us know. And if you can't see Q&A down there, you may have to click on more to find it. Good, keep up the good work here. Let's go have a look at question number 2. Good, so thanks for that for the last question, Jenny. That's right, C was correct. For this question, if you know the answer in advance, neat. But please hold on to it for now. Don't tell us yet. So I want to know from you, do we have anyone here who lives in a city and can walk to things like barbershop, post office? I used to live in New York City, definitely, walking everywhere. What about you? Do you live in a city? Melissa's in Philadelphia. It's probably so snowy right now. Yeah, so some of us do, some of us don't, and maybe you've done this sort of math before in your real life. Mm-hmm, right. Okay. On test day, we would actually recommend drawing this out. But first, I've got a question for you. Do you want to try this question on your own first, or do it together? Please vote in the poll to let us know. Okay, pretty close race. Interesting. All right. By a bit of a margin here, many of us say, let me try on my own first. Okay, I'm going to set you a timer for 2 minutes. And Melissa's going to bring up your poll for the correct answer. And please sketch this out on scratch paper. Count carefully. At the end of the 2 minutes, we'll show you the answer and we'll review. All right, so meet you back here in 2. Let's do it. Welcome back. I see many of us have voted, but some of us have not yet, which might mean you need to boost up. And we've got you covered. The correct answer to this question is D. D is correct. So let's work it out. So on test day, draw yourself a little picture. I'm going to draw myself a little house. I'm pretending it's New York. Okay, so it's like a really, really little apartment like that. And he walks 5 blocks east to the barber shop. Okay, so I would make a little square like this and put a B inside. So I remember that's the barber shop. And then I would put a 5. So I'm like, okay, that's this distance. Okay, 6 blocks west to the grocery store. Okay, so from, I might do this on the next line so I keep everything clear. From the barber shop to the grocery store. So, wow, the grocery store is pretty close to his house, huh? That's pretty nice. So I'm going to put a G over here for grocery store and make a note. Let's see. So B for barber shop, 6 blocks, G for grocery. All right, so far he's walked 11 blocks, right? 5 to the barber shop and then 6 to the grocery, and then 2 more blocks west to the post office. Okay, so maybe I'll put that over here. PO for post office. On test day, I would totally label it out this way. PO for post office. And you can see he's traveling 2 blocks. So 5 and 6 and 2. We're at 13, but is he done? He's not. You're absolutely right. He's not. Because look what happens. Then he walks back home. Fortunately, we have a picture, right? So we can figure out how far it is back to his house. So from the post office, well, back to the grocery is 2. And then back to his house is going to be 1 more. Because remember, the house is 5 blocks from the whatever barber. I was like, bank? Barber. And then 6 to the grocery. So looks like we're gonna need 2 here from post office back to grocery and 1 more to get back to his house. So let's count this up. 5 and 6, 11, 2, 13, 2, 15, oh, 16. Okay, so, you let me know. Please give me a P for picture. If you can be like, the picture really would help me on the test to see what's happening with Bob's adventures. And okay, if not, if you're like cool with the numbers, that's great. And you can see on screen here are the numbers. But I like to make sure I haven't missed anything, and the picture really helps to illustrate that. So if you haven't started drawing some pictures with these, maybe consider it. It could help out. Well, we've talked about the number line so far. We've talked about absolute value and positive difference. And now it's time for a picture of some chickens. Of course it is. You're really not going to believe what I have to tell you about the chickens. Okay, so in May, like Memorial Day, oh, Jen. Let me see if I can restore this. There we go. So in May, my hen hatched 3 chickens. This is what they look like. Yeah, so cute. The little one on the left, I named Rudy. The one in the back, Molly. And the little one sitting down, Bean. Now, given that I only have like 2 other hens, I was hoping all 3 of these were hens. 2 of them turned out to be roosters. Molly in the back and little Bean. So I gave them back to the farm and they're back with their parents, although they don't know who their parents are. So I just have Rudy, but I also got some additional hens because I didn't want Rudy to be by herself. But I'm telling you, Molly became the biggest rooster. He was like dog-sized. It was a little scary. Yeah, and I'm like, oh my goodness, no, no, no. So I was afraid of like him overtaking Rudy. So yeah, he was enormous. Bean stayed small. But yeah. So I still have Rudy, but the others went back to the farm. Great question from Connor. Do you eat? Absolutely not. My chickens are pets, and also the hens like lay eggs for me, so that's good like that. Yeah. So yeah, I mean, I understand you can do that. That's just no, not my jam. Not my jam. All right, good. So at this moment, I want to make sure that you can see. Sometimes when I bring up a picture, you like can't see the slides. Please give me a Y for yes if you're like, oh yeah, I can see that Bob problem again. It's back. Yeah? Cool. Okay, so I like to take a little brain break with the chickens sometimes. You've finished up a good portion of today's class, but let's move next into a discussion of factors and multiples. So a factor is a number that divides evenly into another number. So let's say that you were the owner of a company and you were looking to hire people to work at your company. So you want people who are maybe ambitious and have a great attitude and are reliable and punctual and all that stuff. Those are each factors you'd consider when it comes to hiring somebody. It's not just one thing, right? It's a collection of factors. So think of factors as a collection, a set. A factor is a number that divides evenly into another number. So of these three numbers, which two are the factors? 2 and the 5 are the factors. So every number, like 10, can be broken down into its factors. All right. 2 and 5, factors of 10. All right, you got that one right. So all the pairs of factors that can be multiplied to create a given product can be listed out in a T-chart. You know I love the T-chart. So let's talk about some factors of 10. We already have 2 and 5. What's another pair of numbers we could multiply together to get to 10? 1 and 10. 2 and 5. Minus 1 and minus 10, Debbie. Well done. What's another set? Aha. Minus 1 and minus 10, and minus 2 and minus 5. So factors can always be put onto the T. One number on the left times the other number on the right. Those factors multiplied together get us back to the original. Good. So they would both have to be negative. A good point there from Connor, because negative times negative gives us positive 10. If we had something like negative 2 and positive 5, you're right, that would be not what we're looking for. That would be negative 10. Now, as we step it up a little bit, we're going to talk about solving for the GCF, greatest common factor. The biggest number that the two numbers share that goes into them. And if you're not sure about what I'm talking about, I think with the numbers coming up, it'll be illustrated to you pretty clearly. We're going to use T-chart for the first number, T-chart for the second, and then we're going to find the biggest number we can that matches on the two charts. Okay, so let's find the GCF of 48 and 72. We're going to start with the T-chart for 48. So please share any two numbers you can think of that multiply together to give us 48, that are factors of 48. Good, Takesh with 1 and 48. Good start. 2 and 24. Okay. 4 and 12. Oh, I forgot 3 and 16. Yeah, 4 and 12 and 6 and 8. Now we don't have to go negatives here because we're looking for the greatest value. So the negatives are all going to be smaller. So these are all the positive factors of 48. Let's get some more practice. Now we're going to come up with the factors of 72. So please share any two numbers you can think of that multiply together to give us 72. Good, 1 and 72. Nice D, 2 and 36. What about 3? What about 3? Oh, 3 and 24. That's what I thought you said. Okay, and 4? 4, yeah, 4 and 18. Now, I guess we could keep going, huh? I kind of want to. 4 and 18. 5 doesn't. 6 and 12. Okay. Now, I like to write the whole T out like this. Oh, 8 and 9, right? Oh my gosh, I almost forgot. Thanks, Takesh. 8 and 9. Now, I like to write the whole thing out so I can be sure that I can zero in on the greatest common factor. So notice 24 is circled on the left and 24 is circled on the right. That's the biggest number that these two T-charts have in common. I mean, it's true that 72 is a bigger number, don't get me wrong, but the T-chart on the left doesn't have 72. It's true that the left-hand side, for example, has like 16, but that's not greater than 24. So we're looking at the GCF, the greatest common factor. And we ask ourselves, what's the biggest number that we can find on both charts? Exactly, D. Got to have a match. And we want to have the biggest one because, it's fair. They both have one, right? And they both have two, but those aren't the greatest. Please give me a GCF in the chat if you're like, okay, I can see that visually. Yeah. We make out the two T's and we pick the biggest number what they both have in common. Good. If right now you're like, I'm not sure I totally got that, I want you to come on down to the Q&A at the bottom and chat with Melissa about it, and she'll give you a boost up. So we've been talking about factors, and now we're going to talk a little bit about multiples. Good. Smallest common factor. Yeah, I guess one. I don't think, Connor, I have ever seen a test question asking me for the smallest common factor, but technically I think that you are right. For positive numbers anyway. All right, let's talk about multiples. Sometimes if people have multiple children or multiple babies at once, we can be like, oh, they had twins, they had triples, right? Triplets. So those are multiples. So think of M for multiple and M for many. And I'm going to show you a chart shortly that gives you a breakdown of how to keep straight factors versus multiples. So here's some multiples of 2. Your turn. What if I asked you for some multiples of 3? What numbers would you come up with? Right, you've got the multiples there, 3, 6, 9, 12. And notice that the number itself is always going to be on its own multiple list. It's also on its own factor list. Like 2 is a factor of 2. 2 is also a multiple of 2. So 3 is a factor of 3, and 3 is a multiple of 3. So it always starts with the number itself, because that number times 1, there's a multiple. And then the number times 2, there's the next one. So I have a feeling you have worked with multiples before. So every non-zero number, and by non-zero we mean anything that's not 0, has an infinite number of multiples. Talk to me about infinite. What is the meaning here of infinite? A lot. Yep. Can you tell me more? There's something even more special about it. Goes on forever, right, Dion? Yes, infinity, for example, right? That's a word we know, infinity. So these multiples are infinite. They go on and on and on and on forever. There's never an end. With factors, there's an end, right? We have the T-chart, and that has the whole collection of factors. But multiples go on and on forever. So factors and multiples can be really helpful with fractions. So when we did number sense part 1 on Monday, we were talking about getting common denominators for fractions to be able to add or subtract, and we had to get the LCM, least common multiple, to get the same denominators for those fractions so we can move forward. Good. So here's the secret treasure I was promising you about the chart. Let me show you the chart first, and then we'll come back to this. We'll get to LCM in a hot second, because I really am eager to show you the chart. Okay, here we go. So with factors of a number can be found by dividing, or you could say what numbers multiply together to give us 10, for example. So 2 and 5 we talked about as factors. Multiples can be found by multiplying 2 times 1, 2 times 2, 2 times 3, on to infinity. Factors are less than or equal to the number. So when we made a T-chart for something like 48, the factors of 48, no factor of 48 is greater than 48. 1 times 48, 2 times 24, on and on from there, but the numbers are smaller. It's the reverse for multiples. Multiples start at the number itself and then move on up and up and up, higher and higher and higher. So a cool way to keep straight factors and multiples is to use a little mnemonic device. F for factors, F for few, M for multiples, M for many. Or I like to say a multitude of multiples, a finite number of factors. All right, so now we're going to practice getting the LCM, the least common multiple, which is a skill we worked on a little bit in Number Sense Part 1. But in order to add or subtract fractions, we have to come up with the LCM. Here's a reminder on screen about what LCM is. Be careful about that, Connor. That's not accurate. All right, so the smallest number that is a multiple of both integers. Let's talk about how to find the LCM. List out multiples of the larger number. List out multiples of the smaller number. And then stop when you find a match. So let's find the LCM of 20 and 30. Like if we were adding the fractions 1 over 20 and 1 over 30, we needed to find the least common multiple. Start with your bigger number, 30, and write out a few of those multiples. So your turn. Please share with me a multiple of 30. Like if we had a little list going on, you can start with 30. Those are factors. So go the other way, go the other way. Aha. Okay, so starting with 30, the next multiple would be 60. That's your hint. Ash has 120. I see you, Ash. Aha, okay. Now we're talking about M for multiples, M for many, right? So multiples of 30. 30, 60, 90, 120, on and on. Okay. Now let's talk about the multiples of 20. Share with me a few multiples of 20. We're getting good. Yep. Starting with 20, exactly. 20, 40, 60. Notice that there's a number that matches on the two lists. What is that number? Right. The smallest number that matches is 60. So that's the LCM, the least common multiple. Now, it's true, if we kept going with the multiples of 20, eventually we would get up to 120. That'd be a match for both of them, but it's not the smallest. When we're looking for LCM, we're looking for least common multiple, the smallest number that matches on both lists. So let's remember, for the GCF greatest common factor, we make the T-charts and we pick the biggest number that we can find as a match on both of those T-charts. For LCM, we write out the multiples and we pick the smallest number that we can find that matches on both charts. So it can be helpful to write down on your test when you're moving forward to keep it straight. F for few, like few factors, T-chart. M for multiples, many multiples, up to infinity multiples. And here's the chart that I showed you just a moment ago. Take a moment to review it. And now, time to look at another question. I'm going to bring up the poll to ask you about how you might like to start this question. So please vote in the poll about whether you want to try on your own first or work it together. Okay, thank you. Looks like you want to try on your own first. You got it. Write it all down. Draw yourself pictures. That's what I would do if I were testing. We're going to give you 2 minutes to try it. And Melissa's got your poll for the correct answer. At the end of the 2, we'll show you the answer in review. Let's do it. Welcome back. Good. Many of us have voted A-OK if you are not sure. I'm going to give you another 10 seconds to vote and then we'll review. All right. The correct answer to this question is D. Nicely done. All right, so let's talk about fruit juice. P.S. What is your favorite fruit flavor, even if they don't have that as a juice? Mine is mango. And I've seen mango mixed juices, but like I don't know that I've ever seen like straight up mango juice, which I would love. Mango. Mm. Especially the little yellow ones. I don't know what they're called. But yeah, I've seen like mango mixed juice, but not like straight up mango. Yeah. I think it's because I don't live in a city anymore. I'm sure in New York City it's everywhere. Okay. Thank you for that, Connor. Yes. Awesome. Oh my gosh, pineapple, also delicious. Grape juice. Okay, so we're gonna pretend that this fruit juice container holds 16 servings of your favorite fruit juice. Mm, Paya. Mhm. All right, so the serving size is 6 ounces. All right, so it's important to know that we have two different things we're talking about. One is the fruit juice container, which I'm going to draw like that. That's the thing that we put in the fridge, right? And then one is the little glass that you drink. Okay, so this is 6 ounces. And we're looking for how many ounces for the big thing. And we know that there are 16 servings, and each serving is 6 ounces. So let me make a little note here. We have 16 servings, and each serving is 6 ounces. All right. So to do that, we're going to multiply together the 6 ounce serving. And remember, there are 16 of them in the big container. hmm We just multiply. That's exactly right. hmm So if we do 16 times 6, we're at 96. D for the win. But I do have to say I would draw the picture. Just to make sure I've conceptualized the problem correctly, like there's a container and then there's a small serving, and let me make sure I know what I'm solving for. I'm a big fan of that so that we don't, mix it up or somehow get it turned around. Drawing a picture can really help clarify. Good. Nice. All right, let's go check out another informat question. Take a moment to read about the desert. And please vote in the poll. How would you like to start this question? Do you want to do it together or you want to try it on your own? Mm-hmm. We're feeling pretty ambitious today, I'd say. So good on you. Our class is like, no, let me try it. You've got it. I highly recommend like drawing it out number line style or making whatever notes are convenient for you and make the most sense for you. But I would recommend sketching it out. We're going to give you 2 minutes. Be sure to solve for exactly what the question's asking for, and Melissa's got your poll. All right, so vote when you are ready, and let's begin now. Welcome back. Great, thanks. Almost everyone has voted. I'm going to give us maybe another 15 seconds to vote. Good. All right, time's up. This might be our best performance yet. Look at this. C for the win. You've got it. C is correct. All right, so by the way, do we have anyone here in class that lives in the desert? I have a good friend who lives in just outside Phoenix. Beautiful. And some of us kind of live in the desert. Yeah, I've never lived in the desert. But wow, Chelsea in the high desert, like Colorado, like sounds neat. Great hair day every day. Jealous. Here in Richmond, Virginia, so humid. I do not recommend visiting in summer. It's awful. Oh, Eastern Washington. Got it. Got it. So this person lives in the desert, does seem pretty hot, 92. And the scientists observed the following temperature changes. So it's up 12 degrees. Now, for me, I would actually keep track of the numbers as we go. Up 12, and now we're at what? 104. And then down 5. So I'm like, okay, now we're at 99. I mean, I would do it piece by piece as I go. You don't have to, as you can see on the left, but you can. Adding 6. Okay, so now we're at 105. Subtracting 3. Now we're at 102. And then adding 13 degrees. Oh my. Oh my. Adding 13. So we're at 115. That's really way too hot. So 115 is the correct answer to this question. And I mean, you can put the numbers all together at once, the way I'm showing you with the bracket there, but I like to do it piece by piece, little step at a time to make it more manageable. Mm-hmm. Nice. So yeah, the number line might not be right, the most straightforward way to handle this one, moving back and forth and stuff. And Tanya asked, can we use a calculator? Yep, on the math, you'll be able to use a calculator. That's right. Yep, and that's a great way to do this, as long as we're careful about inputting the numbers correctly, right? So, wow, my goodness, some desert locations, I can't even imagine how hot. I cannot. Well, friend, we have 2 more questions to look at. To be clear, C is the correct answer here. Keep up the good work. Let's have a look at question 5. Well, vote in my poll. Let me know. How shall we start? You want to try on your own first? Correct, incorrect, early answers. We appreciate them, but be sure and put them in the Q&A, okay? Or um, in the host and panelist chat. Okay, good. Almost half of us have voted now to say, let me try on my own first. Okay, very ambitious. I love it. We're going to give you 2 minutes to try this one. Eliminate what you can. And a hint is to change that improper fraction into a mixed number. For example, 8 over 7 would be 1 and 1/7 as a mixed number. So I just made that number up. If you change that minus 16 over 6 into a mixed number, like a whole number and a little fraction afterwards, it might make solving this question easier. That's your hint. See you back here in 2 minutes. Let's do it. Welcome back. I'm going to give you 15 more seconds to vote. Good, thanks for voting. I see this was a good challenge. Nice. All right, the correct answer is B. B is correct. So let's start first changing this improper fraction to a mixed number. To do that, we ask ourselves, how many times does 6 go into 16 without busting? Good, 2. But there's a little remainder, right? 6 goes into 16 two times, which is 12. But there's that little remainder 4 to get from 12 up to 16, remember? And we write that over the original denominator. So you could reduce that down if you want to minus 2 and 2/3. So we are looking for a number on the number line that is at minus 2 and 2/3. All right, share with me one letter where you're like, it's not that. Good, it's so not D. That's in the positive direction. So as soon as you do this, and even knock out just one answer, you're moving it from a blind guess to a strategic guess. What's another number that is definitely not? A. Good, Charlotte. Yeah. Point A is like minus 4 and something. Okay, so we're down to B or C. And B is somewhere in between 2 and 3 on the negative side. That looks good. But C is somewhere in between minus 1 and minus 2, like minus 1.5 or something, maybe minus 1.25. But we're looking for minus 2 and 2/3. So B is going to be the correct one here. So I would highly recommend taking it from an improper fraction minus 16 over 6 and making it a mixed number. So you could then take a couple of points out and then zero in on the correct answer from there. If you have questions, please come chat with us. We can help out. Time for one more question. Oh, I have a feeling I know the answer to the question I'm going to give you, but I'm going to ask you to vote in the poll. How shall we start? Good, almost half of us have voted. All right. Looks like you want to try on your own. Okay, we're going to set your timer for 2 minutes. Write everything down. Melissa's got your poll. See you back here in 2. Good, I'll give you about 15 more seconds to vote. Nice. Last chance. Good. The correct answer to this question is C. C is correct. So loose leaf paper comes only in packages of 400 sheets. Believe it, on test day, I am drawing out a package like this that has 400 sheets. And a student buys enough packages at this store to fill 3 binders with 150 sheets of paper each. All right, so I'm going to draw those smaller binders. And I'm going to make 3 of them. And on test day, I would totally do this to make sure that I can visualize. Okay, fine. What is going on here? All right, so I have these 3. These are my 3 little binders. 400 sheets in the pack. And each binder has 150, right? Room for 150. So will one pack be enough to fill these 3 binders? Right. One pack will not be enough because 150 and 150 and 150 all together would give us 450 sheets, right? And one pack only has 400. Okay, so I guess we have to buy 2 packs then. So I'm going to make a note about another pack down below here. I'll put 1 pack up top, 1 pack at the bottom, 400 sheets here, and 400 sheets over there. Wow. So we're looking at 800 sheets of paper. That's way more than we need. And the question is asking about how many sheets will be left over. So to find that, let's do the 800 sheets we'll have all together minus the 450 that we need for the 3 binders to give us 350. And that makes C the correct answer to this question. So I would highly recommend drawing it out like this so you can really visualize what's going on. But here are the numbers. 450 sheets needed, 400 sheets in a pack, 800 sheets in 2 packs. If you subtract out the 450, 350 sheets left over. Nice job, friend. So here's what we've done today. We talked about whole numbers on the number line, remember? We talked about absolute value, a number's distance from 0 on the number line. We talked about factors and multiples, few factors, many multiples. With factors, we came up with the t, remember? And with multiples, we have a list that goes on to infinity. We talked about relative values. We talked about factoring numbers to find the GCF and the LCM. Now, if there are any questions you would like to see a second time or any topics you'd like to go back and review, please let us know. We're happy to do that. Otherwise, you're free to head out early. Our gift to you. But do let us know if there are any questions you're like, oh, I'd like to see that one again. Happy to do it. You are very welcome. Thank you also, Melissa, our MVP. Where would we be without Melissa? Thanks. Good. Kehlani, you read my mind. That's what I wanted to actually work on. Nice, Rebecca. Visualizing really does help. So I thought that maybe we could do a little practice with factoring using the T. Yeah. Let's go back to do thank you for the nice words in the chat, by the way. Pleasure is all ours. I love to show you pictures of my pets. It's fun. Okay. So I want to go back to the T. All right, here we go. I'm going to make up a number that we're going to practice factoring. That's a very good point there from Tonya. Khan Academy, very helpful for practice if you're like, I'm having trouble coming up with factors. What are factors? How do I do it? Okay, so I'm going to say, let's factor 36. Just made that number up. So we'll now start with 1 and consider the values we can multiply together to get us to 36. So we have 1 and 36. Now move down the chart on the left. Does 2 go into 36? By the way, this is optional. Stick around only if you want to, okay? We're practicing with factoring. Good, oh Jen. Yes, 2 and 18. Okay. Now we go to 3 and we ask ourselves, does 3 go in? Mm-hmm. 3 and 12, looking good. Okay, now we go to 4. Does 4 go in? Yeah. 9. And now we go to 5. Does 5 go in? What about 6? Mm-hmm. 6 and 6. Okay, what about 7? And what about 8? Nope. Now, as soon as you say, and what about 9? Notice that we already have 9 in the T chart. So we don't need to do 9 and 4 here because we already have that pair. So we can stop as soon as we get to a duplicate like that. So we're looking at the factors of 36 here. Let's practice factoring another number. I'm going to say, let's factor 24. Let's factor 24. All right, so we're going to make our T chart. And for the factors, we're always going to start with 1 on the left. 1 and 24. Okay, and then we're going to move up to 2. See how there's an organization here? 2 and 12. Okay. And then good, Pablo. 3 and 8. Looking good. What about 4? Good, Brian. 4 and 6. And what about 5? And what about 6? Oh, but we already have 6 on the right, so we're done. Those are the factors. So there was a student who said, I'm having, oh, right, it was Kaylani. Let me know, Kaylani. You can let me know privately if you're like, this is helping, or if you're like, not yet, not helping yet. We're going to still do another one together. Let's factor 54. Okay, so when we factor 54, what we're doing is looking for the numbers we can multiply together to give us 54. So always start with 1 on the top left and then 54 on the right. It's an even number, so we can be sure that 2 goes into 54. You could use your calculator. Divide 54 by 2. We're at 27. Let's see if 3 goes in. You can use your calculator. 3 times what gives us 54? 18. What about 4? 4 doesn't. Nope. 5 also no. Good, Dakash. What about 6? Yeah, 6 and 9. So 6 times 9, 54. What about 7? 8. And then we're back at 9. So the factor T can help us come up with the full and complete collection of all the factors of a number. Always start with 1 on the top left and then say, can 2 go in? Can 3 go in? Can 4 go in? Can 5? And as soon as you're down to the same number on the left that you have on the right, you can be like, oh, stop, that's the collection. So the good news is with additional practice, it gets easier and easier. We're going to do one more. Let's factor 72. Okay, so we have 1 and 72, of course. That's always where we start. And 2 and what number? 36. And 3 and 24. Okay, you can always use your calculator if you're like, I don't know if 3 goes in there. Okay, 4 goes in, right? 4 times 18, yeah. And then we say, does 5 go in? No. For 5 to go in, the number has to end in a 0 or a 5. 6 goes in. Good. 12 times. And then we say, does 7 go in? It doesn't. 7 times 10 would be 70. So 72 not divisible by 7. But then, yeah, 8 and 9. 10 does not go in. 11 doesn't go in. So the next number is 12. That's our full and complete collection of the factors of 72. So we always start with 1 on the top left and move digit by digit, number by number down on the left-hand side to come up with the full collection? That was a great question. Okay, good. Other questions or places where you're like, I wasn't so sure about this thing. Good, take your time. Okay, while you're thinking about it, oh, absolute value, good, Ash. I think that came before this. Yeah. Number line fractions, good, Kaylani, yeah. Look at both of these. Okay. So on screen at the bottom, you can see the number line that's got fractions. What's the same about this number line and the one at the top is that as the numbers move to the right, the numbers get bigger. So you can think about it in like the bank account. $0 is over here on the left, but as you move to the right, the numbers get bigger and bigger. I think there's a lottery tonight, right? It's like $900 million or something. So that number would be way over here on the right, 900 million. From 0, as we move right, the numbers get bigger and bigger. Now, the same holds true for fractions. So I really liked, I'm not sure who it was, somebody earlier was talking about a quarter of an hour, half an hour. Let's think about that. So if 0 minutes have gone by, okay, a quarter of an hour, for example, would be 15 minutes. 2 over 4 reduces down to half an hour. Now we're at 30 minutes. 3/4 of an hour, 45 minutes, and then 1. If you're baking, adding a quarter of a cup of flour smaller than half a cup of flour, smaller than 3/4 of a cup of flour. And look what happens after that, 1 1/4, even greater than 1. So if you're imagining baking and you need a quarter and a cup, no, a cup and a quarter, how about that, of flour. You would dip the 1 cup in first, right? There's a cup, and then use your little 1/4 cup to get the next piece. So together, it's more than 1. It's 1 1/4. And to the right, 1 1/2. So just like with whole numbers, as fractions move from left to right, they get bigger and bigger as we go. Now, if you prefer it, you can always change those into decimals by using your calculator. You can write that as 0.25, 0.5, 0.75, 1, 1.25, 1, and then, 1.5, 1.5. If it's easier for you to see it this way, you can be like, oh yeah, it's getting bigger and bigger. Oh, Jen, that's 2.5, 1.25. Oh, Jen. Yeah, let me take that out. That should be 2.5. So the decimals can really show you what's going on. Think about it in terms of change. A quarter, 50 cents, 75 cents, $1, $1.25, $1.50. Notice that these are fractions and they're moving up as we go from left to right on the number line. All right, so Kaylani, check in with us and let us know if that helped to add a little clarity there. You're very welcome. Ash, let's go look at absolute value. We know the absolute value of 2 is 2 because the number of steps on the number line from 2 over to 0 is 1, 2 steps. We can also be sure the absolute value of -2 is 2 because the number of steps from -2 over to 0 is 1, 2 steps. Another way to say that is the way I'm writing it up top. The absolute value of 2 is 2, and the absolute value of -2 is also 2. So the absolute value bars really ask us, how far is this number from 0? So when we have those straight lines around a number that stands for absolute value. So let's do a little practice. Like, what is, I'm going to make up some numbers. What is the absolute value of negative 12? Yeah, 12. Totally. Hmm. And what is the absolute value of 37? Also good, Debbie, right? Also 37, right? So the bars tell us that the question is how many steps away from zero is the number inside these bars? I'm going to make up one more little example. What about the absolute value of negative 2/3? You've got it. It's 2/3. So the value after the equal sign is always going to be a positive number. Hmm. Now, sometimes we'll be asked to simplify inside the bars. On the examples I gave you, we didn't have to simplify because those are just some straight up numbers. But for the example at the bottom we did, the absolute value of 2d plus 6, if we know the value of d is 1, well, we can solve. And I'm going to put 1 in for d like this in the next line. So notice 2d plus 6 in that teal color has been replaced in the next line with 2 times 1 plus 6 because they told us d is 1. So when we simplify that out in the next step, it'll be the absolute value of 2 plus 6. After all, 2 times 1 is 2. And that's the same thing as the absolute value of 8. Your turn. What is the absolute value of 8? Good, Dion. We'll do that one next. Aha, 8. Perfect. Okay, so let's do another example. I'm going to make d equal to 10. And we're going to do this exact same example, except instead of d is 1, we're going to put in d is 10. So let me take it back. And I'm going to rewrite this as 2d, so 2 times 10 plus 6. I'll put an absolute value bar at the front that matches. So notice I have taken d out, and in its place, I put the number 10. After all, we're practicing with what happens when d is 10. Okay, so let's take a little further. And we'll find out if Dakesh is right there. So 2 times 10 is going to give us 20. So the absolute value of 20 plus 6. So the first step I'm doing math-wise is the 2 times 10. That's going to give me the absolute value of 26. Let's see. Which is 26, right? So whatever number they tell us d is, we can just plug it right in and solve. So Ash, did that help with your question there? And Dion, did that help with you? I see. Sweet. Nice work. Good. Other questions? It's good to do a little extra practice after class for more clarity, especially when you're like, okay, it was this one that was posing me problems. All right, in the meantime then, I'm gonna have to show you my little kitty, Hiroki Pebbles. There he is. Well, when he was a kitten anyway. Mm-hmm. He's a Himalayan. Yes, he's so soft. His fur is like if you reach into a bag of cotton balls, that's what he feels like. And he's really shy and he's a really teeny little voice and he's like, "Hi, can I have a pet?" He's so cute. Let me show you what he looks like now though. He just turned 6. Let me see. Oh yes, here he is. And people are like, "That's a big cat." I'm like, no. He's actually really small. He just has a lot of floof. A lot, a lot. Now, there was a time I had a mouse in my house, and I was worried. I thought, what if Haruki's just decorative? Is he going to be able to? Oh, he got that mouse. He's like, I am really pretty, but I also have some jobs that I don't slack on. Yep, he got that mouse. And I was like, oh, good. He's decorative and useful. So I'm like, good job, Haruki. But yeah, he's really sweet and gentle. He loves getting snuggles. Oh my goodness. Yeah, so that's my cat Haruki. Goody. Well, we're gonna take you on back over to the end of today's class where we have the learning objectives. Just to show you how far you came in today's class. Don't forget this weekend, I think Benji said he's teaching the GED sessions, and you had a chance to hang out with Benji in our Monday class. So don't miss that this weekend. Here, I'm going to move us this way. There we go. So this is what we've covered today. Melissa's got the PDF for you in the chat there. So if you would like the pages once again, feel free and grab them. Thank you for the extra time. Thank you for the extra effort. And thank you also, Melissa, for such great support. We'll keep the room open for a couple more minutes in case you've got questions. Otherwise, look forward to seeing you again in the GED classroom. Thanks again. Good night.